Hello everyone, I'm Kesav Rai and I'm a professional chemistry teacher here at Cantok for the past 7 to 8 years. So with a view to helping those students who cannot reach me, I'm creating this YouTube channel and uploading this first video for them. I hope you all will find it helpful, and if you like, please do share and subscribe. So without wasting much of our time, let us dive into the topic. So for the first video, I'm taking this topic, dehydration of alcohol. This is important for both the class 11 and the 12 students. For class 11, it is there in the hydrocarbon section in organic chemistry, and for class 12, it is there in the reactions of alcohol. And in addition to that, it is also important for NEET and JEE aspirants. So let us dive into the topic. So the dehydration of alcohol. Now what do we understand by the term dehydration of alcohol? Dehydration simply means the removal of water. If the term hydration comes, hydration means you are adding water onto it, but the term dehydration means you have to remove water. Just to remove water, you need a dehydrating agent. A given reactant simply will not be able to lose water molecule, and for that you need a dehydrating agent. And the most common and the most powerful dehydrating agent that we usually use is concentrated sulfuric acid at around 443 Kelvin. There are other reagents too, but here we will put special focus on this reagent, concentrated sulfuric acid at 443 Kelvin. Now, a given alcohol, when they are treated with concentrated sulfuric acid at around 443 Kelvin, it will always give rise to the formation of alkenes. Alkenes means a double bonded compound. Here, you must keep in mind that alcohol always has this OH term, and this R means it shouldn't be equal to a benzene ring, neither it should be equal to metals. R means an alkyl group. That means the example can be methyl, ethyl, propyl, butyl, hexyl and all. If OH is attached with the alkyl group, not with the benzene ring or the metals, they will be referred as alcohols, and alcohols on treatment with this concentrated sulfuric acid at 443 Kelvin, it will give rise to the formation of alkene. Now I'll give you several examples for that. So this is CH3CH2OH, the most common alcohol. The name is ethanol. Now if you are reacting this with concentrated sulfuric acid, 443 Kelvin, the dehydrating agent, what will it do? The OH is attached with this carbon, and that carbon is actually referred as alpha carbon. And this alpha carbon is again attached with another carbon, and that carbon is known as beta carbon. Now, during dehydration of alcohol, you have to remove one hydrogen atom from beta carbon. And if you remove one hydrogen from beta carbon, you have to remove one hydrogen from beta carbon and the OH group from the alpha carbon. Now you are removing H from beta carbon and OH from the alpha carbon. Now the remaining will make a product. That means the only remaining thing is CH2. Since you have removed one hydrogen, only left is CH2. And there is always a single bond in between alpha and the beta carbon, so you have to keep that single bond as it is. But since you are removing one hydrogen from here and one OH from here, there will be two non-bonding orbitals. Since both hydrogen and OH is being lost, two non-bonding orbitals will come together and form another bond. That is why there will be a formation of double bond over there. And alpha carbon, it has CH2 group, it will remain as it is. That means CH2 double bond CH2, that is ethene, will be formed. So from ethanol, it will always give rise to ethanol. Similarly, this is propanol or simply propanol 1. OH is attached with the alpha carbon, and that alpha carbon is actually related with the beta carbon. Another carbon is actually referred as gamma carbon, delta carbon and so on, but we don't have to deal with the other carbons. We are only concerned with the beta carbon. Now, just like in the above case, you have to remove one hydrogen from beta carbon and the OH from alpha carbon. And due to the removal of H and OH, that is water from there, you have to write the product CH3, CH, alpha beta carbon will simply have CH, and there will be obviously a double bond in between alpha carbon and beta carbon, and there will be CH2, the leftover CH2 from the alpha carbon. That means propane 1 mole will create propene. Similarly, here also OH is attached with this carbon, alpha carbon, this is a beta carbon. And beta carbon has one hydrogen atom, this hydrogen should be removed, and the OH, this hydrogen and the OH should be removed, and by the removal of H and OH you will get the product, and the product will be CH3C and CH3. You are removing this beta hydrogen, that is why in between alpha and beta position you will have double bond and CH2 will follow. So this is your corresponding alkene. Similarly, this is a bond line molecular formula. OH is attached with this carbon, so this is alpha carbon. And again, this alpha carbon is attached with this carbon, this is beta carbon. So here there is a carbon, and this carbon is forming two bonds at two different directions, this and this. That means this carbon must have two more hydrogen atoms. Now, one hydrogen will be lost from this position and the OH from this position, and due to that, the formation of product will be just like this. This will remain as it is. In between alpha and beta, there will be a double bond, so this is the product. In the similar way, over here, OH is attached with this carbon. Here there is a carbon, alpha carbon. And if this is your alpha carbon, this is your beta, and this is your beta carbon. Since both the beta carbons are in the same environment, you can either use hydrogen from here or from here to obtain the product. Now, if you remove hydrogen from here, this carbon has two bonds, and if you remove one hydrogen from here and OH from this carbon, what happens? It will lead to the formation of product, and this will be the product. In between alpha and beta position, there will be a double bond. This is a cyclohexane. Cyclohexanol is actually giving you cyclohexane. So this is how dehydration of alcohol should be done. And for the mechanism portion, we have to deal with the mechanism too. For the mechanism portion, I'll be uploading another video. So for today, this much for today. Thank you all.